This is the May 2013 exam paper for SE0EM2. Question 1 is about differentiation, but before we start it, may I remind you of this publication from the Learning Development Centre in the library. You can get a copy of this from the first floor of the library, and in addition to the formulae, it has a table of differentials and a table of integrals, and I'll be using these during these videos. So, back to question 1. Each of the terms in this expression is either added or subtracted from the previous one, which means that we can differentiate this term by term. So we'll start with the x to the 7. This is the line we need. The differential of x to the n is nx to the n minus 1. So when n is 7, this will be 7 times x to the power of 6. So there we are. The next term is e to the 5x. The differential of e to the x is e to the x. But if it's e to the 5x, we need to multiply it by the differential of 5x, which is 5. So the differential of e to the 5x is 5e to the 5x. The next term is minus 2 log x. The differential of log x is 1 over x. So the differential of minus 2 log x is minus 2 over x. And then finally we've got plus 3 cos x. The differential of cos x is minus sin x. So the differential of 3 cos x is minus 3 sin x. And this is the answer to part A. Part B. We need to differentiate x plus 4 times sin x. Now this is a product, so let's remind ourselves of the product rule. d by dx of uv is equal to u dv dx plus v du dx. So let x plus 4 equal u and sin x equal v. So the first term is u dv dx, which is x plus 4 times cos x. And then we have v du dx, which is just sin x. And that's the answer to part B. Now we have to differentiate x over the square root of x squared minus 1. Let's remind ourselves of the quotient rule. d by dx of u over v is equal to v du dx minus u dv dx all over v squared. X is equal to u, and the square root of x squared minus 1 is equal to v. So we have v du dx minus u dv dx. The square root of x squared plus 1 is the same as x squared plus 1 to the power of a half. So that gives us the u term here times half times the bracket, and then we reduce the power by 1, so that gives us minus a half, and then we multiply by the differential of the bracket. The 1 will disappear, so we'll just end up with a 2x, and then this is all over v squared. Now that's the square root of x squared plus 1, so when that's squared we get x squared plus 1. Now let's see what we can do with this. We've got x over 2 times 2x, which gives me x squared, but then we've got this term here which is x squared plus 1 to the minus half. So if I multiply top and bottom by x squared plus 1 to the half, this term will cancel to 1. This will become x squared plus 1, and the denominator will become x squared plus 1 to the 3 over 2. Now we've got x squared minus x squared, so they'll cancel. So the expression will simplify to 1 over x plus 1 to the power of 3 over 2. And that's the answer to part C.